Hello everyone, my name is Kieran Dove and this is my second workshop from my Master of Landscape Architecture degree. Alright, so my question, or my title was the Parametric Landscape. How can hierarchies and spatial relationships of landscape architectural elements be made explicit using associative design? Landscape architects are becoming more and more involved in highly complex jobs. Also, the growing need for designers to work collaboratively within these large teams is becoming more and more often. With contemporary methodologies not handling this complexity to the best ability, a need for a new type of methodology I think is needed. Through my research earlier on, I looked into digital design, which I believe to be a family of methodologies which could give something new to these complex designs. At first, digital design was a representational tool, but over time it has developed into a series of methodologies such as morphological design, generative design, performative design, and parametric design. One in particular I was interested in was associative design. In associative design, we have a system of formal geometric relationships that are defined by an algorithm, and these geometric relationships are controlled by two types of values. Some are fixed, others can vary. Ones that can vary are called parameters. Once they have certain arrangements, and when one or more parameters are at different values, there is a change in the formal geometry of the outcome. This is how, by assigning different parameters, we don't get the simple solution, we get a whole family of well-defined solutions. Going into examples where parametric or associative design has been used, the Alicante train stop is a design to turn a traffic island into a public space. With a tram stop at the centre of the traffic island, accessibility and amenity had to be created to create a pleasant and enjoyable space. The tram stop design inputs started from the roundabout circular shape with a location, a centre point and a radius. The design of the plaza will then fit within these parameters. The formation of the pathway starts at either end of the circle. A triangular grid of points is then laid out and then connected to set out the initial pathway. Points are connected to make lines, so carrying on this idea of geometry being created. With a series of lines created along the points are then moved to create different configurations. The final network could either be optimized in order to achieve a predefined set of rules, like shortest distance for each pathway, put through a randomized generator or controlled by the designer. The network of lines is then offset in order to create a flat NURB surface that represents the pathways. A set of meshes is then generated from the areas within, defined between the edges of the NURB surfaces and the outlines of the circle. These NURB surfaces represent the grassed areas. The control points of the meshes can then be manipulated to create various mount-like 3D geometries. So, just in the triangles in the middle. Moving on to a second case study, a theoretical one in a research project like this. The Flux City idea is located in an urban environment with a strong presence of heavy industrial buildings. The major inputs for this design are the contamination sites of the area. Points are located at the centre of these contamination sites and are the main influence for the design. With the location of the points being the contamination sites, a grid is overlaid to signify and represent the new roading network. The points act as a repelling entity which pushes the grid and forms it. This creates the new roading network. From the deformed grid, the lines are offset to create a surface that represents the roads. The roads are then given different widths to show the road hierarchy. This then creates the spaces between the road surfaces, which become the building parcels. A height is then added to the parcels to create buildings. The height of the buildings are dictated on a proximity rule to the contamination sites. The further away, the higher the building. The important points I took from these two case studies and many more I researched is the way in which objects relate to one another and the different forms of this relationship, and how the process of generation of geometry can start from a single point and flow on, and setting up these hierarchical relationships which help form the design. Now moving on to my case site, which I will be using these techniques to investigate. Shoal Bay is the area, so just over the harbour bridge on the North Shore. So shown here is the historical photos of what used to be there, Sulphur Beach and City of Cork Beach. And in the 1950s, the motorway came through and severed that connection the coastline had with the local communities, and shown what conditions there are now. Stormwater issues, spatial issues with a lot of constraints with widths. There are rich flora in the tough crater and the domain and along the coast where the remnant Putakawa groves are, and access, which is limited with only several access points. Through the use of GIS analysis, I was able to get spatial information that will later help inform my design. Shown here is a handful of required research maps that will be put into the design to help deform and to create the shapes and the surfaces and the design. With all these pieces of information, I could then create a vision for the site. Shown here is a design strategy plan, which will help guide the design and placement of the interactions and influences. This plan was done implicitly in a traditional manner by a designer as a representational drawing of a proposed outcome. Associated design will then be used to help develop and design within this plan the smaller components and slices to see how all these influences are affecting one another, and to create a family of outputs. For example, looking at the headland created at interchange in the beach and how they can relate to one another. And with that hierarchical kind of relationship, is the beach kind of forming the headland shape, or the headland kind of creating a shelter for the beach, for the beach to form. So creating these links and these relationships to help inform the design, and then following down through how all the parts interact with the new adjusting coastline of the headland and the activities that will happen on it, maybe seating or utilities, light poles, bins, information boards. Just a representational drawing of two sites that I have investigated. There will be more to come in my next presentation. So zooming into site A at the northern end, as I look at the conditions, it's evident that two distinctive constraints are visible straight away: the edge of the motorway and the coastline. So taking those and using those relationships to help form my design within that space is a good starting point. Overlaying a design strategy helps identify the overall hierarchy of the site and shows the kind of relationships that are likely to be created. For example, the activation of the site is going to be hinged on the shape of the landform and the incorporation of the view shafts. This will mean a sweeping pathway close to the coast will allow for the appropriate angles to maximise seating placements for the views. The planting is also a major component, which is not directly related to the pathway or any of the components on land, but will be determined by a separate set of rules, which will come from a variety of professional inputs from ecologists, stormwater engineers. The planting locations could be set up to replicate the existing extent or change with the addition of other factors such as tidal fluctuations, sea level rise, soil sand conditions, and the plant type selected. And again, a representational plan of a design iteration with those considerations noted with the seats, wanting to maximise the views, how would that deform the pathway, and showing that hierarchical kind of relationship with the coast, with the constraints being at the top, followed by the view shafts, kind of helping orientate the direction of the pathway, and then offsetting some of the amenity trees and some of the other features to be that will go on there. Design site B, shown here, again, similar conditions with, as the motorway edge and the coastal edge being two constraints. As before, the activity of the site plays an important role in developing the relationships for the design. The site is designed as a pocket park in between large planted areas. The lawn area is then in the middle. With the motorway and coastal edge constraining the site, the primary pathway becomes the top of the hierarchy of the hierarchy, which guides the other design components. A secondary path is created to sit between the pathway and the seawall, and becomes a geometry that is always at a tangent to the seawall as an explicit rule that you can will always stay constant no matter how the main primary pathway moves and shifts around. The lawn area in the middle is created from the isolation of the pathways of the surrounding pathways in isolation. The lawn is then filled with components such as seats, bins, lights, trees, etc. These components have their own set of rules, such as the seating with the distance offset from the path and the concrete pad it sits on being offset from the extent of the seat. So if another seat was extended, the pathway would automatically extend the required offset from the edge of the new seat. Rules around placements of bins, etc. Could follow council standards and predefined dimensions set by suppliers. The design of the seating, for example, will be created from a set of relationships such as orientation, length, width, under or outside of the shaded trees, the number of seats required, impervious and pervious surface ratio requirements for the space if it came down to that kind of detailed design.
5 minutes.
Yeah. So looking at the components which make up this design and the relationships that they could have, as discussed in my case studies, the strong control of geometry was important within all my elements and others not shown. These small components show different scenarios I'll be using to show how geometry relates to its surrounding influences. The attract and repel deforming technique is one I use often and is suitable for a lot of design problems. Examples are attraction to a significant feature like a bridge connection, repel or attract to archaeological sites, creating planting plans dependent on a distance from a certain feature like a stormwater outlet. Adding small relationships as well is important to help fill the design, such as the trees or a light pole offset from the edge of the pathway along the whole pathway. And with the strong component and kind of use of associated design is the idea of iterations and having an initial model and just changing some of the parameters and getting a whole new design and a set of designs with a series of smaller changes, adding small pieces to it that added depth. These took 10 minutes to create with the variation, so time and the outcome, it's a lot quicker than drawing each new design again and again and again, as we do at the moment. Again, moving into a smaller, just a simple idea of a jetty, the orientation of the headland, is it on an axis or is it perpendicular to a curve? So all these types of relationships need to be thought of and controlled within the program to help just for a stronger control of the design and help with all the iterations. Looking at stormwater outlets, typical kind of scenario down the coastline. Planting, how spacing of planting, the relationship that the plants have with the stormwater pipe, more intensive planting around the exit of the pipe, so more remediation purposes, further away from anti-planting. Again, looking at planting on the tough craters and some of the large revegetation, taken into kind of other professions, ecologists, having their inputs, seeing how their kind of ideas change the design, the requirements change the design, stormwater engineers, geologists, how we can add these little components in and how they relate and then the forms that are created. The addition of trees with the idea of taking away the plants that were beneath them, and that controlling and kind of the idea of iterations and keep producing and producing.
2 minutes.
Yeah. Again, the pathways which I showed in the first illustrated plan, and the other one kind of showing these relationships. If it moves, what happens with the path, what happens with the seating, what happens with the trees, the offsets. So, in conclusion, in creating my designs, I examined how the creation of relationships and hierarchies can improve the design process and its results. I demonstrated that the complex relationships that were able to produce several design options that accelerated and exceeded the capabilities of traditional representational techniques. This was most notable when designing the primary pathway system, which had several influences and relationships, but also sat at different levels of the hierarchy at different times. This integration allowed the complex interactions between landscape elements to be explored quickly and easily, creating a more considered and precise design. It is significant that this process could not have been easily repeated using traditional design techniques. Also, the way in which form generation is capable and easy to manipulate brings the potential for incorporating this with community consultations, where people will most likely enjoy seeing the change in front of them as they contribute to the design. For landscape architects, computation offers a medium ensuring their message that landscapes are dynamic entities which demand an explicit and interdeterminate approach to the design process. This dictate is best tackled using computational tools such as associative design that are uniquely capable of conceptually expressing and technically resolving the complexities that we are facing at the moment, or soon to be facing as these jobs start arising and we get more and more involved with them. So moreover, the kind of next step is adding that complexity and kind of adding a bit more depth and length into these designs, merging two or three of them together, finding out their interactions and finishing off some of those larger design areas and finding out their influences and relationships with one another to try and get a novel design or a series of outcomes to look at.
Great, thanks very much, Kieran. So I'd like to invite panelists to contribute first for 20 minutes, but also encourage everyone in the audience to also be part of this conversation and to contribute to Kieran's work. Okay, so who wants to kick off?
Nice.
I think this is fantastic as an idea. I think it's going to be idea of trying to break new territory and where landscape can go pushing into its realm, which I think it's a really, really exciting thing, and not only potentially for maybe looking at something that is to solve a site or two sites, but what is the future? How can it actually be used as a tool for working at multiple sites? There's a few things I'm jumping to a bit of critiquing here, but you seem to almost arrive at a solution, and then it feels like you almost sense it as a bit of post-rationalisation. And I kind of wonder about if you be taking ecological rules and parameters, setting those up first, which might be about the bigger stuff. And then the objects themselves, which is where you seem to be placing bins and chairs and stuff, is secondary as the attractors and detractors.
Yeah. And
so, because you wonder about you almost kind of arrive at a solution. You think, well, if you're using parametric modeling and you're using it for a way which is doing option studies, it'd be nice to know you have no idea what the answer is, but you put in your parameters, you set the rules, and then you get some answers. And then you can do a whole series of option studies, which then start to test different scenarios. Because I think that's where you want to try and arrive at, is outcomes that you don't know are possible. I think. And that's where this can be powerful as opposed to sort of falling back to the generic. I found your last images really quite exciting. You might say, well, this is an attractor, detractor. What does it actually do to manipulate the path? But if you did the entire landscape, it would be really interesting to see.
Yeah, that's complexity.
You got all that other stuff in it. This is a piece of land. What does it do? How does it motorway affect it? How does the other estuaries? And so suddenly it's not just a good bulge, it's maybe has to be a completely different shape.
No, definitely that's the idea is to get all those influences, say, on the path, which would be the most effective being throughout the whole site. How it is archaeological, how does the landform, how does the motorway, how does the noise, how do the bridges, how the tons of factors influence it, and that kind of weird geometries that it creates. Is kind of the idea where you want to be heading for all those options.
I can think of it might be a Melbourne research organisation, and I'm trying to think of his name, sent to Matthew. But these guys have done, they've done a whole series of, they look at the ideas of option analysis, whereby, from an architectural point of view, you might look at the facade and we say, well, here you get a client to present 3 options, there's A, B, and C, and you've generated by going, well, I think this, you get another one, you get another one. And they kind of look at it from the point of saying, well, if you can plug in some parameters as to what you're trying to achieve, you might have 4 rules. Solar shading is one. There might be heat gain, something else, and then there might be outlook. And then they can say, well, we want to base it on something like green design. So there's those rules, and then it just computer generates hundreds of options. And then you, as a designer, you almost have your control is aesthetic choice as to which one you think might look better than the other. And I think that's quite interesting, and I think this could be fascinating if you start exploring and researching the endless possibilities.
Great. Thanks, Kieran, and coming at this as a non-specialist in the area and looking at this as a research question. I think this is a great question. You start with an open question, beginning with how does this improve results, I guess, is your basic question, I think. It seems that you focused very much on some of the technical questions, like is it quicker, is it easier, does it produce more options as we go, so to speak. You don't have to start from scratch, I think is perhaps your point. We don't have to redo the drawing, as it were, from scratch. So there's a technical efficiency gain in this technology, as I understand it. There's one really fascinating thing for me. This is my prejudice, if you like, given my background, so it may not be entirely relevant to you, but one of the really fascinating things that you hinted at was that people can see changes happening as they say something like, oh, what would happen if we expanded this area over here, or if someone came along. So I'm just sort of thinking off the top of my head, there's a lot of windsurfers use the bay. What if they were to say to you, oh, we'd like some kind of launching pad, so to speak, whatever the word is, for our windsurfers, and what effect would that have on other parameters? And you would, what I'm hearing you say is that this would be something that you can incorporate very quickly. They'd be able to see the effect that it would have on other users or other uses or other essential aspects of the design. So in other words, what I'm getting at is that this seems like a fantastic tool for consultation purposes. And I'm wondering, how does that fit into your research question? Or have I just thrown a completely irrelevant thing at you?
No, I've noted that kind of the consultation, like a local person kind of over the shoulder saying, oh, what happens if there's 10 seats? I think I'll sit there more than, a lot of people will sit there more than you'll put 2 chairs in. So it's that, that over the shoulder, put more in, and then as those relationships created, that everything adjusts. That part should sweep more. I like that view that's a bit more out here. So a lot of those on-the-spot design iterations.
And it also means that one group of users who might have one demand can see what effect their idea would have on other users.
Exactly.
Couldn't they? They'd then be forced to visibly see, if we get what we want, it's going to constrain what other users might want, questions like that.
And that's actually good with that. If they have that parameter and their parameter, you can easily try go 50-50 and actually see where that lies. There's a lot of that quick testing with them over the shoulder to say, move that plant or move this coastline. And then with the other guy, the engineer, saying, no, actually pull it back. It's actually good to see them. They can get that discussion going on the spot without sending a drawing back 2 days later. And they're like, change it.
Right.
Which is a kind of in that collaborative kind of environment where a lot of jobs, big jobs, they actually have their own studio and working together. They can just be there to have a quick look, which is kind of a key component idea, which will be great.
Again for me, I'm sort of outside this field, but just my initial thoughts were obviously again it's really interesting to hear about it, and I thought the one thing that I thought would be interesting to hear more about was how specifically it might fit within other professionals, so the landscape architect, geologist, and that kind of thing, and how they would all use or potentially use this tool together. I thought that might be something to develop on or hear more about. I'm not sure, you mentioned it a little bit, and I just thought that sort of struck me as interesting, how it could be used in the future, and how this sort of tool, would be efficient and that sort of thing. So that was my sort of main thought here, maybe could be developed on. Is that something that you were sort of...
I'm not sure what's happening overseas with the people that actually use it day to day, like Europe and America. I'm sure there is a lot of that collaboration and that sharing of information. And I suppose for kind of the program, it takes in numbers, it takes in bits of information. So if there was a process or kind of if they gave us points to put into a file, like these archaeological sites or a line, geological boundary, those could all be incorporated in quite happily. And I suppose it is just the native program. If one has that, it would be nice. But it is something that can be powerful in that kind of collaborative way.
I've had a go at doing something like this for some complex
how did that
stuff. No, very good. Because some stuff that we've been doing was like large-scale master plans. And when people change and move things, they go, we're not going to do this, let's do this first. They seem to forget, because of the complexity of what the impact that has on things. And so you can link all the critical parts together. So if you're going to do this program out, the effect's going to be that you affect all of this, and then your dollars change down here, and your time changes up here. And trying to get them to see quite quickly as to how the impact of the decision.
Yeah, definitely. I've come across that at work as well. Master planning, moving big sites, a road, and the numbers, and updating spreadsheets. So definitely speeding that process up and linking those together would be save a lot of time. And provide that instant feedback as well, because again, it's an instant change, it's an instant update of the other information, the spreadsheets, the numbers, which, as you say, would be a lot better, a lot quicker, and give that feedback straight away to whoever was given it.
The question is how big do you go, because you can start with getting small parameters sorted out, and then you can grow as you start. Too big.
It starts with the small components again. It comes from a library of parts. So you've got the library of all your little components. You pick which ones you want. You click them together. It gets bigger. It gets more complex. It gets to whatever stage it needs to be at. And then from there, those all little tweaks. If you built it right, show that change to how you want it to be kind of thing. With that really tight control. So that could be...
It kind of alludes to the
reflection I was going to ask you to make on the pitfalls of, the system. I think the critics have highlighted some really great potentials, and it's possible. But from the other angle of the pitfalls, I'll ask you to tell me what you think. There's the two angles to approach the project. There's from the small scale and put all the elements together and build it up that way. But what do you think? What in your experience of working with the system, what do you have to watch out for from the big scale?
I haven't really done much big scale stuff.
I guess what I was wanting you to tell me about were the kind of big scale goals and the framework that the council had for your project as a kind of preface to what you were doing. So, and I guess the other thing for me is that sort of, the design of poetics and analysing the site character. So do you think the system enables you to bring that side of what the designer brings to the project in?
I'm just going to say yes. I suppose bringing the designer into it is, I suppose, part of the process as well. Picking things that you want as a designer, if you go that route, or let the program pick it. But maybe or even just look into next, get a better answer for you. But I'd say yes for the time being.
Yeah, sure.
Ask me if you
Can I ask a question? How come, with the setting of your rules and your parameters, how contestable is that? So if you're deciding how far a seat is from a path or whatever, how clear how rules bound is that, or how contestable is it, and how is that process of setting your parameters?
They've done using sliders and kind of values, which I think that's pretty set in stone, those types of things. And if it does have come in conflict with something, like if it doesn't get the minimum spacing, because it may overlap the pathway or something, there are ways of just kind of program telling you those things, and you can also set limitations on programs. So the curvature of a pathway can be set. The minimum distance of a grass lawn can be set to counteract those possibly.
So some of those parameters are design decisions, is that what
are they? Like you set the width, you set the length, spacing, you set the strength of the repel and the attract. It's all controllable by the design.
I suppose it jars with me a little bit, because I suppose thinking as a designer, my experience as a designer when I'm real old school, but I think my whole intention always with the design is to break the rules as much as possible, and to have that element of surprise. Something happened which, I wouldn't have thought of that, and so that's what I'm wondering, is how you actually, maybe you use it to sort of set up the infrastructure so that it all technically works, but then you give it to the designer to sort of throw it onto the drawing board and scribble all over it and do something completely different with it.
Or do you do that first and then you use it?
Well, the idea is that you do draw things out like I've done, implicitly drawing the master plan, or the strategy saying, these things, and then kind of getting those points. But you do a design, you set 4 parameters, you get 10,000 whatever it is, that's different options for that. A lot of them you wouldn't have thought of. So those things like, wow, I never thought of that, but the rules that I've set, it still fits within it.
Yeah, that does generate.
So you get those wow types of you're saying the pathway, like, oh wow, it does this. I never would have thought of that. And there's a million other options like that within the parameters that you set and the rules that you've set. So it doesn't break them, it doesn't go outside your boundaries, it doesn't do loop and crossing things. It still fits the design.
Fair enough.
More questions?
Not make some
supervisor, so
Yeah.
I can tell him what I think after.
Definitely after.
But maybe you could, do you think you could maybe just a few concluding remarks to kind of contextualise?
Yeah. So I guess the whole argument is kind of made it quite sort of clear. It's about these rules, they make the form generation explicit, while in a traditional paper-based or CAD design is implicit. So even though what you mentioned about drawing by hand and innovative stuff, it's arguably innovative as well. Yes, so
Yeah, that's limited.
in what way it is innovative, or in what way this one can be innovative. What is important though is that the form generation is explicit, so it is up for discussion as well. The rules are for discussion because they can be clearly seen by other experts in the definition, which consists of small square components linked together, and it is said what each component does. So the overall conceptualization might be implicit and but the form generation is explicit, and what the important parameters in their hierarchies are also explicit. So the whole form generation is up for discussion as well, and can be also easily altered. Apart from variations of the design, the rules are also explicit, which is quite useful, which is not so in traditional canonical design method, and just the designer interacts with the design and constantly changes it intuitively.
Okay, so I think
So
on that-
that was, I guess, the way Kieran just wants to prove or disprove his points or find the boundaries to his design.
Right.
So,
That's really helpful.
thanks.
Thanks so much, Kieran. Okay, 2 minutes for our, we'll come up for our next presentation.